Hello and welcome. In this video, we'll explore the real-world value of linear equations and how they play a crucial role in our daily lives. By the end, you will have a clear understanding of why learning linear equations is essential and how they apply to everyday situations. What makes this video unique is that you can jump straight to the topic that interests you using the YouTube chapter division listed in the description below. But that's not all. I have also prepared extra practice problems to help reinforce what you have learned. You can find them on my Google website. Check the link in the description below. If you find this video helpful, don't forget to like, subscribe, and hit the notification bell so you can never miss out on new math content. Now, if you need one-on-one help, you can connect with me on Fiverr or Upwork using the links provided. Before we dive in, let's take a quick look at what we will cover in this video. First, we will start with an introduction. Why are linear equations important, and how do they show up in everyday life? Next, we will explore real-world applications of linear equations, including financial planning and budgeting, shopping and discounts, fitness and health goals, sharing and splitting costs, cooking and recipes, and predicting trends. Remember, you can jump to any section that interests you using a YouTube chapter marks in the description. Now, let's get started. No one wants to learn a skill that they cannot immediately use. We all want to make sure that the time we spend learning something is worthwhile. So, we're going to have to ask the question, why is solving linear equations important? And how can a high schooler use this skill in their everyday lives? Here, I am going to give you 7 reasons why solving linear equations is important skill for high schoolers to learn. First, you could use this skill in a real life application. Solving linear equations is used in various real life situations, like financial planning, shopping and discounts, fitness and health goals, sharing and splitting costs, cooking and recipes, traveling and commuting, and predicting trends. In this video,
The
I will show
student
you
will
how
be
solving
working.
linear equations applies to each of these examples. Second, it's a skill that is good for decision making. Learning to solve linear equations help a student make informed decisions, such as budgeting for purchase or compare service plans. In other words, it helps you choose the best option when you're faced with a financial decision. Third, it prepares you for a career and future opportunities. Many careers, such as in engineering, computer science, finance, and data analysis, require a solid understanding of linear equations to solve real world problems. Even lawyers rely on math skills in their work. Mastering this skill opens door to numerous professional fields. Fourth, it's a foundation for advanced math. Linear equations are foundational for more advanced math, such as Algebra 2, Calculus, and beyond. Mastering them now prepare you for future academic challenges, and it is essential for anyone interested in pursuing higher level careers that require advanced math skills. Fifth, it develops your critical thinking. Solving linear equations sharpens critical thinking by helping you analyze relationship between variables, such as cause and effect. Think of solving a puzzle. It might not change your day, but it trains your brain to think logically and piece things together. It improves your problem solving skills. Solving linear equations enhance logical thinking and problem solving ability. Whether it's schoolwork or personal challenges, learning to approach and solve problems is strengthening your ability to tackle life obstacles. Finally, it helps you build confidence in math. Mastering linear equations build confidence in your math skills. As you gain competence in solving equations, you will find that this confidence translate to success in other areas, not just math. That being said, it's good to conclude that the purpose of school is to challenge you, prepare you for life and your future career. Let's look at this real world problem and how we could use linear equations, or how is linear equations used to solve such a problem. First, I like to start with the actual question, which in this case, how many weeks will it take for the student to save enough money? Knowing that we are looking for positive income, we're going to start reading the problem and collecting all the informations that we need. Let's read the question. A student is saving money to buy a laptop. They already have 100 saved up. So they already have $100. So this is a positive 100, okay? This is an income that they already have. They plan to save 25 each week from their part-time job, okay? So again, this is a positive income of 25 per week, okay? But they also have a one-time expense of $40 for a new backpack, okay? So this is a negative income, okay? Because it's an expense. So it's going to be minus $40, okay? They want to buy the laptop, which costs $600. This is our final result. This is what we want to collect altogether. So we know that our final result need to be 600. And whatever we are going to add need to add up to 600. So we already know that we have $100 saved up. However, we're going to have to subtract that 40 because we're going to spend $40. And then we're going to have a weekly income of $25. So this is another positive income, 25. It's not it's 25 per week. And we need to know how many weeks will it take for the student to save enough money. Okay? So that means we need to multiply that 25 by how many weeks. Keep in mind the question is asking me how many weeks will it take for the student to save enough money. Okay, so W here stands for weeks, right? Because I'm going to save $25 per week. To solve for W, I want to find a way to isolate my W. So to do this, first I'm going to combine like terms. Right here, 100 minus 40 is 60. And I'm just going to drop the 25W. And I'm going to subtract 60 from both sides because the opposite of addition is subtraction. I'm going to be left with 540. And then the opposite of multiplication is division, so I'm going to divide by 25 from both sides. 21.6 weeks to be able to get to that $600.
That starting on the sixth day,
That's my final answer.
they plan to increase their
Now let's see
distance
how
by
solving
2
linear equation
miles
can apply
each
to
day.
shopping and discounts.
So that means
Let's
every
read the
single
question.
day
A
they're
student wants
increasing
to
their
buy a
distance by 2
$60 pair of
miles compared
shoes
to the day
that are
before.
on sale for 25% off. Additionally, they have a $7 coupon. What is the final cost of the shoes? Now, we know the original cost of the shoes are $60. And here we have two kind of discounts. We have the 25% off and we have the $7 coupon.
Let me show you how you convert from percentage to decimals. 25%, anytime you see that percentage, it's out of 100. So it's the same thing as 25 divided by 100. If you put this on a calculator, let me show you, you'll get 25 divided by 100, you'll get 0.25. That's how you change a percentage to a decimal. Another way you could do it is because if you have
Now,
those two
having a better
zeros
idea of the
in the
problem,
100,
let's go ahead
you can
and
just
write a
move your
single
decimal back.
equation
So you have
that represent
$25.
this
Your
problem.
decimal is right here. You just move it back twice. Your decimal moves back and you put a zero here. That's another way to do it without a calculator. And the reason you're going back with the decimal is because you're dividing. If you're multiplying, the decimal would move to the front. But because we're dividing, we're moving back twice. That being said, if I ask you what is 10% of a $10, you would do 0.10, 10% times $10, you would get 1. Okay, so 10% out of a $10 is 1. What about 20% out of $10? So 20% would be 0.20 times $10. You would get $2. Okay, now the question becomes in this problem, what is 25% of 60? So we do 0.25 times 60, you would get $15. So anytime you want to get a certain percentage from an amount, you multiply. So here, 25% of 60 is $15. So what we did 0.25 times 60, we got $15. Now let's take a look back at our problem. We're trying to get the final cost of the shoes. You know that your original cost of the shoes is $60. And you have two kind of discounts. You have the $7, so we're going to subtract 7, and then you have the 15. So you're going to subtract the 15. Okay? When you apply 60 minus 7 minus 15, you'll get $38. That's your final answer. Let's see how solving for linear equation could be applied to fitness and health goals. Let's look at the example provided. A student runs 4 miles every day for the first 5 days of the week. Then, starting on day 6, they plan to increase their distance by 2 miles each day. After X days, they want to know when the total distance they have run equals 40 miles. How many days will it take for the student to reach 40 miles? So we want to know how many days will it take for the student to reach 40 miles. That means their goal is to run 40 miles. So 40 miles is their goal. So the student want to run a total altogether of 40 miles. Now it says the student ran 4 miles every day for the first 5 days of the week. So how do we know how many miles the student ran in the first 5 days? So what we do is we multiply 4 times 5 because the student ran 4 miles each day for 5 days will give us how many altogether the student ran for the entire 5 days. That means the student ran for the entire 5 days 20 miles. So that means on the 5th day, the student was running 4 miles. On the 6th day, now the student would add 2 to that 4 miles, so we'd be running 6 miles. On the seventh day, you would add another 2. That'll be 8 miles. So that means each new day, the student would add 2 mile. Each new day, the student would add another 2 mile. Okay. Now, they want to know how many days would it take the student to get to 40 miles total? Keep in mind, total. Now, there's something that you need to keep in mind. The student already ran 20 miles. That means from the 40, you subtract the 20, so the students still have another 20 miles to run. And we already multiplied 4 times 5. So that's your first part of the equation. Then, starting on day 6, he or she is adding 2 miles each day. So we're going to add 2 miles each day. Okay, so I'm multiplying 2 times x. Now, keep in mind, you need to subtract the first 5 days. You need to subtract the first 5 days from x, okay? Because you don't want to include that because you already included it here. So you want to subtract 5. And then your total need to be 40 altogether. Okay, so let's recap. The 4 times 5 is because the student already ran 4 miles for the first 5 days. Now the students need to add 2 miles each day because x is representing each day, but we're subtracting 5 because we already included the 5 right here in the first 5 days. Okay, and then we're setting it equal to 40 because that's the total miles that we want. Now let's solve for x. So the first thing we do is multiply 4 times 5, you get 20. Okay, that means the students already ran 20 miles, which we already know. And then you will distribute 2 times x, you get 2x. And then 2 times 5 will get you negative 10. Now you combine like terms. So you have 20, negative 10, you're left with 10 plus 2x equal 40. You need to isolate your x, so you deal with the 10 first. So the opposite of positive 10 is negative 10. So this is 0. Left with 2x equal 30 divided by 2 divided by 2. This will be 1. You'll get x equal 15. And that's your final answer. So we'll take the students 15 days to run a total of 40 miles. Let's see how solving linear equation could be applied to sharing and splitting cost. Let's read the example given. 5 students went to a concert and the total ticket cost was 150. They decided to split the cost equally, but one friend only has 25 at the time of payment. How much do the other 4 students need to pay to cover the full cost? And how much will each of the 5 friends end up paying in total? Here you have a total of 5 friends who are going to a concert that cost a total of 150. So logically here, to get to how many each need to pay, you would do 150 divided by 5, right? But they're saying that one of the friend could only pay $25. So that means you'll do 150 minus 25, okay? Because one of the friend can already pay that. That means the other 4 friends are left with 125 to pay. Now you will divide this payment by 4 because you're left with the other 4 friends that need to cover that 125 cost. That means each person would pay $31.25. Now you might ask me, okay, how could I put this into an equation? Now we know that the total cost is 150. We know that the first friend could only pay $25, and the rest of the other 4 friends will pay the rest. Okay. Now 4 here represents the other 4 friends, and X here represents how much each person would pay. And to solve for X here, you need to isolate X. So that means you need to get rid of the added 25 and the multiplied 4. So we're going to subtract 25 by each side, and then you'll be left with 125. And then the opposite of multiplication is division, 5 by 4. So you would be left with X equal 31.25. This is the total amount of how much each of the other 4 friends would pay. Now let's see how solving for a linear equation can apply to cooking and recipes. Let's read the example given. A recipe is designed to make 4 servings and require 2 cups of flour. If the student needs to adjust the recipe to make 6 servings, they could use a proportion to determine how much flour is needed. Now here, the recipe that calls for 2 cups of flours can only serve 4 people, okay? What if you want to do 6 servings instead of 4 servings? How many cups of flour would you need here? Let me visualize it here. 2 cups of flour would give you 4 servings. Therefore, how many cups of flour would give you 6 servings? Now you could use fractions to solve this problem. How many cups of flour does it really take to just make 1 serving? It takes 2 cups of flour. You divide it by 4 serving, right? You would get half. That means it takes half a cup per serving. The reason you divide 2 divided by 4 is because you want to divide the 2 cups into 4 servings in order to know how much flours does it take to get just 1 serving. And we know it's going to be half a cup. Now, if you multiply that half cup by 6, it would give you how many cups you need in order to get 6 servings. So if you do half times 6, you would get 3 cups. So that means it takes 3 cups to make 6 servings. Now, that being said, you're going to ask, how could I write a linear equation out of this? So let's do that. Let's call this question mark right here, which is how many flours we need to make 6 serving. Let's call this X. Now, remember how to get a single serving, we did 2 divided by 4? Now, wouldn't also X divided by 6 get us a single serving? Yes. Now, that means 2 divided by 4 would actually equal to X divided by 6. Now you have a linear equation where you can actually solve for X. How would you do this? How would you solve for X here? You have a divided 6. So the opposite of division is multiplication. So you multiply 6 from both sides. You want to keep that balance. Now this is technically 6 divided by 6 because 6 is in your numerator and the other 6 in your denominator. So it would be actually 1. So you're just left with x by itself. Here you would do 2 times 6, which is 12, and 12 divided by 4 is 3. So your final answer is x equal 3. That's how many cups of flour it would take to make 6 servings.
Now, let's see how solving for linear equation can relate to predicting trends. Let's read the example given here. A student is starting a small business selling custom t-shirts. The cost to produce each shirt is $10, and they also have a startup cost of $100 for equipment and materials. The student sells each t-shirt for $25. How many t-shirts do they need to sell in order to make a profit of $200? So let's line out what is given and what we need to find. The student here want to make a profit of $200. Let's say profit, P, will be $200. To do this question correctly, you have to know what is a profit. So let's talk about what is a profit. A profit is the money you have left after you pay all your expenses. Now that means profit will equal to the money that the student will make from selling the t-shirts minus the amount of money the student will spend to produce those two t-shirts. We know that to produce each single shirt, it costs $10. Okay, so let's label T for t-shirts. To produce the t-shirt, it costs $10 per t-shirt. Now there's a fixed price that the student have to pay for equipment and materials, which is $100. Okay, so I'm gonna say F for fixed price, $100. That student has to pay that $100 regardless of how many t-shirts the student produce. Now, how much does each t-shirt cost to sell them? Okay, so selling a t-shirt, it says it will cost $25 per shirt. So let's say T for selling, $25 per t-shirt. Now the problem wants to know how many t-shirts do they need to sell in order to make a profit of 200. Here in this problem, they do not say that there will be any wasted t-shirt. They're basically saying that whatever the student produce, the number of t-shirts the student produce, will be all the t-shirts the student will sell. So we're going to assume the S produced, the shirts produced, will equal the shirts sold. Let's look at our profit equation. The profit needs to be 200. So the profit is given $200. Now, how much does the student makes from selling the t-shirts? Well, we know that each t-shirt will cost the customer $25. So $25. We don't know the number of shirts. So it's going to be multiplied by S. Because if you multiply 25 by how many shirts you're going to sell, it's going to give you the total cost of how much the student made from selling all these t-shirts. So if the student sold one t-shirt, 25 times 1 will be 25. If the student sold two t-shirts, 25 times 2 will be 50. Now moving on to producing the t-shirts. So how much did it cost the student to produce the t-shirts? And we know there's a fixed payment of $100. So the student have to pay $100 plus
the $10 per shirt. So $10 times S, which stands for the number of shirts that the student is going to produce and sell. Because remember, we said that we're going to make them equal. We're going to put these in parentheses because both of these are going to be subtracted from the total money the student made. Because remember, profit is how much money the student made after takes in consideration the cost of producing the t-shirt. So whatever is in the parentheses, that's the total cost it will take to produce the t-shirts. So we're subtracting how much the student will make from selling the t-shirt by how much it takes the student to produce the t-shirts in order to calculate the profit. Now we need to solve for S. Remember my video about how to solve linear equation? I said the first thing that you'll need to do is get rid of parentheses. So we're going to distribute the negative sign in order to get rid of that parentheses. So we're going to distribute. So negative times 100 is negative 100. And negative times 10s is negative 10s. Because remember, negative times positive, it's negative. And then everything else that I did not work with, I'm just going to drop it because I didn't change anything to them. Now I'm going to combine like terms. So I have 25s here and I have 10s here. So 25 minus 10 is 15. So I have 15s. Everything that I did not work with, I'm just going to drop it. No changes so far. To solve for my s, I need to isolate my s. So far, my s is being accompanied by the 15, the multiplied 15, and the subtracted 100. Now, following the rule of combining like term, I'm going to start with my negative or subtracted 100. So in order to get rid of that subtracted 100, I'm going to do the opposite of negative, which is positive. So I'm going to add 100 to both sides. So on this side, I'm going to have 300 equal to 15s. And here I'll get 0 because negative 100 plus 100 is 0. They cancel each other out. And then to get rid of that multiplied 15, I'm going to do the opposite of multiplication, which is division. So I'm going to divide by 15. Divide by 15, because whatever I do on one side, I have to do it on the other side. Now, this is here is going to be 1, because any number divided by itself is 1. So I'm going to be left with s equal 300 divided by 15 will be 20. So that means the student need to produce and sell 20 t-shirts in order to make a profit of $200.